All right, so in this video, we're going to take a look at something called the unit circle here. So what we have is we've got a circle, and we're going to say that the radius is 1 around this circle. And so what we have is these values going around the circle. If we had more time, we could, show and explain kind of where these values come from, but it kind of has to actually do from our right triangle trig. So actually, I'm going to send this file to everybody so that they've got it, so that you can use this to help you with your Khan Academy stuff. Just a real quick idea of kind of how this works here. You can actually draw a triangle inside of this circle. And if you do, any point on that circle has an XY coordinate here, and then the left and the right, or the horizontal component, is your X, the vertical is your Y. So that's where we get our X and our Y here. Now, if you guys remember anything about our SOHCAHTOA trig here, remember, SOHCAHTOA, the sine was the opposite over the hypotenuse. Well, if I look here, from this angle going around the circle here, we call that theta, all right? This y is the opposite, and then we said that the radius was 1. So if I want the sine of this triangle, it's just the y value of this ordered pair. And then if I wanted to do the cosine, that's the adjacent over the hypotenuse. Well, the adjacent for this angle here is the x value. Okay, that's next to the angle right here. All right, and then the hypotenuse is 1 again. So if I wanted the cosine of this angle, all I have to do is look at the circle here, and that is the x value. All right, and then there's a nice little reminder here on the sheet. Again, I'm going to send you this file, that the sine is the y and the cosine is the x. So we can use this to kind of evaluate different angles for sines and cosines, and that's what we're going to be looking at here. So just to give you some quick examples here, all right, for degrees, let's say I've got sine of 30 degrees here, all right? Well, if I look at my unit circle, I'm going to find 30 degrees. Here's 30 degrees. And then if I want the sine, we just said that was the y value. So I'm going to look here at the ordered pair, and all the ordered pairs kind of go with the, if you think of these like spokes of a wheel, this one goes that way, this spoke goes to that ordered pair, and it's the 45 degrees. The 60 degree spoke goes with that one, 90 degrees is this one, and so on and so forth. Okay, we'll talk about that in this other thing in a second here. But for 30 degrees, the sine is going to be 1/2. All right, so sine of 30 degrees equals 1/2. And if we had more time, we talk about how no matter what triangle, the size of the triangle, if you had a 30-degree angle in a right triangle, the sine, the ratio would always have to be 1/2, no matter how big it was. It would always reduce to 1/2. But, all right, and if I want let's do a cosine here real quick. So let's say I want the cosine of 225 degrees. So again, I'm going to look at my unit circle. I'm going to find the angle of 225 degrees. Okay, and it always, just a quick note, you start at 0 degrees and you wrap around counterclockwise. And then if you remember, when I get to the end of a circle here, that's going to be 360 degrees. And I would highly suggest that if you print this off for yourself, that you put that there. So you know that 0 and 360 are the same. But at 225 degrees, I'm going to look at my unit circle. And we just said the cosine was the x. So the cosine of 225 would be negative root 2 over 2. So cosine of 25, negative root 2 over 2. All right, now let's talk about this. So in geometry, we talk a little bit about radian angles. And basically, you're just talking about, you're going around the circle, and it has to do with how many, if I took this as one radius, how many radiuses or radii can I wrap around the circle here? If you remember anything, it had something to do with the circumference going all the way around the circle equal 2 pi r. Actually, so if I go all the way around the circle, that's 2 pi radians. So 360 degrees is equal to 2 pi radians. So that means if I only go halfway around the circle, half of this is pi radians. And then we can do some fractions here, like half of this is 90 degrees, so that's pi over 2, or 1/2 pi. If I do half of a half, I'm at 45 degrees, or pi over 4. And then we've got some other ones here, pi over 6 and pi over 3. So let's say I wanted to do the sine of 5 pi over 4. So that's bigger than 1. So I need to at least go halfway around the circle. And if I can find 5 pi over 4 here. And by the way, most of the angles that they're going to ask you to evaluate should be on the unit circle here. You can do other ones, but we're just sticking with the nice ones, or the ones that pop up the most here. So at 5 pi over 4, I wanted the sine. So again, the sine is the y value. So negative root 2 over 2. All right, and then one more example here. I've got the cosine of 3 pi over 2. So again, that's bigger than 1, so I've just got to find 3 pi over 2, which would be right here. Cosine was the x value we said, so that's equal to 0. All right, so that's kind of a quick down and dirty review of how to use a unit circle here and kind of what you're doing with it. Again, if you've got any questions, please send me an email. If you're going through Khan Academy, you've got a question about a specific problem that you're looking at, take a screen cap, send that to me so I can answer. I can't answer I don't get it, but I can answer a specific question if you send me one. Or see me on the Google Meet, and we can do a face-to-face and help you out that way. All right, have a good week, stay safe, and we'll get through this together.